For most of human history, the night sky was a mystery, an endless canvas of moving lights that no one truly understood. But more than 4,000 years ago, one ancient civilization began to notice something extraordinary: patterns, cycles, rhythms hidden in the heavens. They were the Babylonians, and long before the Greeks, long before Rome, long before modern science, they built one of the earliest scientific traditions in the world, a system of astronomy so advanced that parts of it remained unmatched for 2,000 years. This is the story of how the Babylonians learned to predict the cosmos. Imagine standing atop a mud brick ziggurat in ancient Mesopotamia. The city below glows with lamplight. The night sky above is impossibly clear. And on the rooftop, a group of scholar priests, known as the Tupshar Inu Anu Enlil, begin their nightly ritual. They record the positions of planets, the brightness of stars, the shape of the moon, and even the color of the sunset. Every detail matters. Every change could mean something. To them, the sky was not simply beautiful. It was a message. The Babylonians are often remembered for their myths, their kings, and their hanging gardens. But their greatest legacy may be something quieter and far more profound. They were the world's first long-term astronomers. Where earlier cultures simply observed celestial events, the Babylonians measured them. They created tablets filled with numbers, diagrams, predictions, and corrections. Generations of scholars copied these records, preserving centuries of data, long enough to reveal recurring cycles in the sky. And one discovery became legendary: the Saros cycle, a repeating pattern of eclipses every 18 days, 11 hours, and 8. They did not know why eclipses happened, but they knew exactly when they would happen. How did a civilization without telescopes, without advanced mathematics, without metal instruments, achieve something so accurate? The answer lies in their method. First, the Babylonians were obsessive observers. They tracked the motions of the moon with astonishing precision, measuring its rising and setting times, its angular speed, even the slight wobble in its orbit. Second, they developed mathematical tools centuries ahead of their time. They used a base 60 number system, sexagesimal, which made dividing the sky far easier than the base 10 system we use today. Because of this, they created the foundations of what would eventually become 360-degree circles, 60-minute hours, 60-second minutes. Every clock you've ever used, every map, every navigation system, all trace their origin back to ancient Babylon. But their most surprising achievement was their understanding of planetary motion. To most ancient cultures, planets wandered randomly across the sky, but Babylonian scholars detected subtle patterns in their behavior. They noticed that Jupiter, for example, completed its path across the sky and returned to nearly the same point every 12 years. They observed Saturn repeating its cycle every 29.5 years. They tracked Venus through an 8-year loop, so precise that modern astronomers still marvel at the accuracy. These cycles allowed them to construct predictive models so advanced that in 2015, scholars discovered something astonishing. One Babylonian tablet uses a geometric method of calculating Jupiter's motion, the same technique used in 14th century European mathematics. This means the Babylonians invented this idea 1,400 years before the first medieval mathematicians. But Babylonian astronomy was not purely scientific. It was deeply spiritual. To them, the sky reflected the will of the gods. Eclipses warned of danger. Comets signaled major events. The movement of Venus could foretell war or peace. This combination of science and divination created a strange but powerful hybrid system, half prophecy, half mathematics. Yet it was precisely this blend that kept scholars observing the sky for centuries. The predictions had to be perfect. Lives, harvests, and kingdoms depended on them. And so, generation after generation, they refined their numbers, corrected their tablets, improved their methods, slowly turning superstition into science. When the Persian Empire conquered Babylon, they preserved the astronomical tradition. When Alexander the Great marched across Mesopotamia, his scholars studied Babylonian star tables. And when Greek thinkers like Hipparchus and Ptolemy built the foundations of Western astronomy, they relied heavily on Babylonian data. In other words, the first astronomers in the Western world learned from the first astronomers in the ancient Near East. Even today, modern researchers rely on Babylonian records to reconstruct ancient eclipses and understand Earth's rotation. Their work still matters. The Babylonians did not imagine themselves as scientists. They saw themselves as interpreters, readers of a divine cosmic script. But in their attempt to understand the will of the heavens, they created one of the earliest scientific traditions known to humanity, a tradition built on patience, on precision, on the belief that the universe follows patterns that humans can discover if we look long enough. And though their temples have crumbled, their empire long vanished, their clay tablets remain, quiet, fragile, and filled with numbers that once unlocked the sky. The Babylonians did not just watch the stars. They predicted them. And in doing so, they changed the story of human knowledge forever.
Subscribe to ERA by ERA channel.